Hello everybody, I am Sahana Das. I'm hoping all of you are doing great. I am here to explain you the KMP algorithm. So this algorithm is used to match strings or a given pattern in a big string, in a main string. It uses the degenerating property that eliminates the backtracking. So without further ado, let's get right into it.
So before we go ahead with KMP and understand its working, it's necessary for us to understand the basic naive approach. So let's go into it. So we're given a string of length 12 and a pattern of length 5, and our aim is to find out if this pattern of length 5 is in the string, in the given string. So let's start with the naive approach. What we do is we use an index I in J. So we are going to compare the values at the indexes I and J. So at the string at I we have A, and at J we have A, so it matches. So we go to the next character. So for the next, let's go I as B, B matches, next C, C matches, D, D matches, A and F. So here we do not have a match. So there is a mismatch here. So what we do is we have to backtrack. And so we found there's a backtrack, and now because of the mismatch we begin again. So now a new I starts from B, and we again start with B, B match, B, the C and C is a match, D and D is a match, and then there's a mismatch again. So then just now we have seen that we are going to see the characters that we have already compared with. So this is a waste of time, and backtracking of I results in time complexity of O, big O of M into N, where M is the length of the string and N is the length of the pattern. Now that we have a brief idea of the naive approach, let's move towards KMP. Okay, so before we begin with KMP, there's certain terminologies that we should be aware of. Pattern, of course, the given pattern, and then there's something called a prefix and a suffix. So coming back to the terminologies, what is a prefix? So by prefix, we mean a certain number of characters from the pattern that we can subdivide. So it can be 1, 2, a group of 3, anything. So A is a prefix because it starts from here. We can take AB. AB is a prefix. ABC is a prefix. ABCD is a prefix. Similarly, coming to suffix. So suffix is again subsets of the pattern from the right, as in from the end. So it can be C, C, BC, ABC, DABC, it can be anything. So what are we supposed to do? Let's check what is common, the common subset of a prefix and a suffix. AC, AB, no. So we find ABC is common. So this is something we were supposed to know. And now when we proceed towards the KMP algorithm, we are supposed to make a pi table or an LPC. LPC is longest prefix suffix. So let's take an example to understand better. Fine. So in this is pattern 1. So let's just by a glance at it, what do we see? That we have AB, AB, AB in common. So let's make indices. This is 1 and 2. So let's start writing where are they repeated. We write 1 and 2, they're repeated here. 1 and 2, they're repeated here. The rest of them are zeros. So this is our pi table. Similarly, if we take a glance at this, there is ABC, ABC repeated, and there's AB. Again, looking at the indices, so this should be 0, 0, 0, because this is 1, 2, 1, 2, 3, 0, 0, 0. So these were some basics that we need to know before we proceed to the actual KMP. So let's go ahead. So this is an example that we have to see how KMP works. This is a length of 15 characters of the given string, and this is the pattern that we're supposed to find out. Writing down the indices. This is what. So let's make our pi table. This is A, B, D, and so these are the indices. And let's make the pi table. This is 1, this is index 1, so we have a repetition here, and this should be 0, 0, 0. So let's proceed to KMP. Proceeding to KMP, we're going to take a 0 index at first, and then there's an I here and a J. So the J begins from here. So what we are going to compare is the I and J plus 1. So let's start. So A and J plus 1 is A. There's a match. So when there's a match, we shift I here, and next J is this. So let's see, B and J plus 1, that is B. There's a match again. So now this is J, this is I. So A and J plus 1, A, there's a match. So let's shift I, and this is J. So I and J plus 1, there's a match. Let's shift I, and this is J. So I is C and J plus 1 is T. There's a mismatch. So this is something we should understand. What are we supposed to do in case of a mismatch? So in case of a mismatch, we are supposed to go to the index where let us say, so we're supposed to go to 0. You see, we go back to 0. Now again, this is our J, this is our I. Let's proceed. I, J plus 1. Mismatch. So because there's mismatch and we cannot go further left from 0, we shift this to be I. So I hope you guys got what we're doing here. So now this is our new I, and let's go. This is a J. So I and J plus 1 match. Let's shift. This is I and J plus 1 match. Let's shift I, J plus 1. There's not a match. So now we go back to this index, and that is, this is our new J now. So let's see. This is our I and J plus 1. No match. So where we go to 0. Now if we further continue in this way, we find out that this is our common pattern that is found. So I hope you guys have got a brief idea of how KMP works. Thank you. That's all for the video.